Hey, how's it going? So, I wanted to do something again for my Patreons. I wanted to make some AI, and I wanted to get into a little more detail. We had a discussion yesterday in the Playmaker Discord, actually, about I guess more or less skill levels and where we are and who's collectively where to go from that. And if you look at a lot of my tutorials, I do a lot of advanced things, no doubt. I tackle a lot of crazy things. A lot of the other tutorials out there, even right from the official Playmaker site, they're far simpler, I guess you could say, in many aspects. They're good, don't get me wrong. But I typically go with a lot more of the complex stuff, and I thought I would put this one in. I'll do chapters on this one so you can go through. But I have AI, and more importantly, I made some actions for the AI to make your lives a lot easier. And I wanted to kind of go about that. So the first thing I wanted to do, though, is kind of talk roughly about AI. So there's a few things about AI. One thing is, don't bother trying to trick an AI, right? I find that to be a common mistake where you try to build this AI and it's based on this reactional system where it's you almost want to make a living, I guess, and it's very hard to do, and it's very buggy. You got to remember that AI know everything. They know where your player is, the speeds are, they know the attack swings, they know everything there is. The trick is to program them to make them dumber than that, not go from blank and try to make them smart. So if I had play, so you have a few different states. We'll get into that first. Actually, I don't know if I should get into that. Maybe I'll get into the navigation. So I'm going to use NavMesh. And if you look at, for example, I have a plane and a box here. This box, if I mark it static, and I go to my navigation, and I hit bake, it bakes this lovely blue thing around my scene. This is important because when you have AI, the AI move based unless you're going to go completely different system, I guess. They have to have this NavMesh agent component, and this component reads this thing and it reacts. So when it comes to the NavMesh component itself, it does not care about walls. It does not care about windows. It does not care about doors, elevations, nothing. The only thing it sees is this blue mesh. So if this thing wasn't baked, if I rebake it and it's not there, it's there physically. It's there. It has a collider. My AI have a collider. If the AI wants to go to this box, it will try to go right through that frickin' thing because it does not realize it needs to calculate a path around it, because as far as it's concerned, it can cut through it. So normally you mark things as static on the navigation and you bake them. Now the AI NavMesh component knows that if it wants to go over here, it can't cross that. It has to go around. With that said, the other thing you also could do is, say I bake this. Oh, whoops. I want my ground to be static, the box non-static. Now, on the box, I technically could put a NavMesh obstacle, and if I tell it to carve, and I go here. Where is my box? Why can't I see my box? What did I do to my gizmos? Oh, geez. Lord Thunder, you got it on the wrong thing. Supposed to be putting it on the cube. So, NavMesh box, right? And I tell it to carve. So it runs a box pretty much the same as this box collider anyways, right? It even looks the same. And you're probably thinking like, okay, well, what the hell does this do? And what it does is it tells this NavMesh to cut it and say, hey, I'm here, right? But the beauty part is I can actually move it now, and I can cut that NavMesh anywhere. A little more performance. So usually as things are moving, it's not cutting, and when it stops, it cuts, and that's where you kind of see this move threshold time to stationary. But anyways, I thought I'd show you that. So it's very important to realize that your NavMesh agent that you're running your AI on doesn't care about geometry. They care about this blue thing. If the blue thing moves up, right? Like if I take my plane now and move it, that NavMesh is still there. As far as the AI is concerned, whether it's running physics or not, it's running on this blue thing, and that's how it's going to move. It does not care about the ground. Okay, so keep that in mind. Let's stick that back there, somewhere in there. In fact, I could rebake it because it's probably not even straight. Not that it matters, but I will anyways because it drives me nuts. So, okay, so AI. So I built this AI, and I built them in a ways where I have an empty, and then I have the model underneath it, and that makes it really easy to swap this model out. Like I could literally just delete this model, grab any other model I want. Right, I've got a bunch of Cinti stuff here because I use it all the time for stuff. It's simple. I'll grab another zombie though because I like the zombie, and stick them there, and it'll actually work the same as long as I tell my system that the model is that. Okay, so AI need a couple states, and if I said I built some states, and we're gonna look at those. Pretty, and there's a bunch of pretty colors here. I'll get into those after. So I built some simple states here. We have a wandering state, an idle state, a chasing a player state, and attacking a player state. Now I've done custom actions for, well, 3 of those. But the idea, okay, wander. So I built an action that's wander. It just does the wander for you. And that's actually where we see some of this stuff. Let me turn off this one. So I built a wander state, and it has debugging, so it's kind of nice that way, where we can adjust its wander range to go anywhere we want. I also added a slider, so this is a chance. So as it moves, so it'll randomly choose a position somewhere in this circle, and then once it gets there, it runs this chance. Right now it's 100% chance, and if it gets that, it does the is idle event. Right, so we're in the wandering state. Once we get this event, we're going to transition over. Now nothing in here is running, nothing. Right, we're going to be running just this guy, and this one here just does a random wait, and then it's going to go back to the wander, and that's it. Now this is a great place if you have the animations for idle animations and sounds and stuff like that. You could play the idle animation. So he wanders over, maybe plays an idle animation, wanders over here, stops, idles, plays another animation, and you kind of start to get this bit of a almost a personality to him. Now it's important though, and I've seen this happen numerous times. So I set the animator float for a speed in this state, but I need to do it again in this state because these two states aren't linked. You got to keep that in mind. And I've seen that numerous times with newer people, where they'll put a bunch of actions in one and they go through and they'll be wondering why certain things aren't updating value wise, and that's because if it's not in the state, it ain't happening. So we have this wander, and all it does is it takes, and you could totally do this on your own thing, right? I can even show you, get position, and we could do a random float, probably need a couple of those, right? And we could do like a -50 to a 50 and call that like an X, and a -50 and a 50 and call that a Z. Do a vector 3 set XY, and right, so okay, so first of all, ideally, normally you would get your position. Where are we? Store that position. So that would be our position. And then we would say, okay, let's generate our two random floats somewhere between -50 and 50, which technically this gives a box, not a circle, but no biggie. And then we want to create a new vector, not our position. Call this one like an offset. And we want to set our X. Ooh. Oh, I thought I could have sworn, unless it's like a global. Oops, messed that one up, didn't I? Right, and we've set our offset vector to our random floats. So we don't care about the floats per se, we care more about this vector. But then we can say vector 3 add, or vector 3 operator and do an adding operation, and say take our position, add our offset to it, make sure everything happens in order, so make sure to put these things in order. And then once we have that, we could tell the AI to move there. But what if you were standing over here and the target position was over here? You can't move over there. There's nothing there. So the AI would fail and it would be like, oh my god, I'm broken. So we add this new, or not a new action, but another action called NavMesh sample position. And what this action does is we give it a source position. So I'm going to use our position, which is modified because we've added those two random floats to it. And we're going to say give us, a distance of say 20, and the nearest point found is actually from this hit thing, and this is our returned value. And now that we got the returned value, so essentially we say, okay, our random point will say over here. This thing will say, okay, there is no NavMesh here, but the nearest point on the NavMesh to this position is say here. So there you can have this position. That's what comes back. So now that we have that, then we could set agent destination. Move to the bottom. And we would go to the returned position, right? And if I set that actually as a start state, you'll see if I hit play, he should get his position, do the floats, add it, sample position, find a new position, and move there. And that's kind of what he's doing, right? So that's kind of one piece of logic for a wander, because that's one part of it, right? But now we would need to build, okay, we have reached our destination, we need to run this logic again, or if we want the idle chance, we'd have to build that whole thing into it as well. So what I did is I took all of that, I compressed it into this, right? And then gave it some nice debug so that we can play with it. But it's doing the exact same thing. You can also turn the debugs off and on, right? To control our wander range, our chance. The other thing is that from here, if I wanted to control the animation, say he's walking, I would have to say okay, we're doing this, so you are moving. Or I have to go into the NavMesh agent component, grab its velocity, pull out the magnitude of the velocity, convert that into a float, and transport it into the animator, which just sounds like a whole lot of steps. It's not really that bad, but enough steps, and then run off it. So I built that into my wander action, and that's where you have a target move speed, so you can control the speed for your wander, and then we have a current move speed that it spits out for how we're actually moving, and then we can take that, and in this case I'm just going to use a set animator float, and I built speed. Right, so that's kind of how that works. Now if I look at my animator, now in this particular, and he doesn't have it, so I'm going to have to give him an animator, because my other zombie had it and this guy doesn't. I don't know which one I was using. It's one of those. Not that one. That guy. Yeah, that'll work. I'm not going to use root motion. That's your animations are driving the speed, and you can do it. It complicates things, screws things up. So in my animator, so your animator has to go on your model that has the structure and stuff. So in the animator, like an animator, if you don't know what an animator is, it's kind of like a collection of animations, but more than a collection. It can have parameters, and it can tell you which animation you're playing to which animation. You can blend them, almost like we're building an FSM, but inside the animator, right? And that's what these things look like, and they are probably shockingly scary to some people. Right, so a lot of these I'm not even using. They're part of something else. Actually, I'm not even using these two either. I'll get rid of those over there. So I've made a blend tree. So I made a float parameter by adding a float. I called it speed. Right, and I can create a blend tree like that, which is what I did here. And if I double click it, I go into the blend tree. So this thing will blend, and I can change different blends. So I'm using a 1D blend based on the speed parameter. So if it's 0, I want to be playing an idle. If it's 0.4, I play walk. If it's 3, I play run. But the blend tree will do everything in between as well. Right? Like if I hit play, I can actually drag this, and I can see there's my idle. And as I move up, they're walking, kind of doing this weird little walk. And they start hopping, going, and then there they are, they're running. So that's, and you can see it like this is where we're at, and you can run this blend. You could also do a 3D blend. I won't get into those today. So then I also made two different attacks. Now I'll get into those maybe a little later, but really all they are is I use triggers. Triggers work just like bools. A bool's true and false, and you have to swap it back and forth. A trigger is technically like a bool, but once you use it once, it's gone. So in this case, if I get the trigger 1, I do this attack, and then he goes back into his locomotion. I never have to say, stop doing this trigger. It'll activate once, and then it's used up and it's gone. So triggers are kind of cool for that, compared to bools. Bools definitely have their place, though. Don't get me wrong, I use bools a lot as well. All right, so back into this. So we have what's coming out as a speed, which is actually feeding into us from the NavMesh agent, and that's what I stuff into the animator itself. As you see, I say, okay, we're going to take our model. We have a parameter named speed, and I'm going to feed it the speed. It's coming out of there. I'm also going to use a damp time, so it's not just a solid, here's the number. It actually kind of feeds it in at kind of like a lerping effect. And you can see if I hit play, let's go over to our scene. They are walking, and they're playing that animation. And if I want them to move a little faster, I can actually speed him up, and he speeds up and plays the right animations. Right, so you kind of have to adjust and play depending on your models and your animations. But yeah, so that's the wander. But it'll wander that range, possibly do an idle. Right, I can bring that down, or take it up, whatever, no matter. And he'll go over to whatever position that he chose, moving at this speed, and then actually I can crank that right up, and then he'll choose a new position and he'll go there. And it's controlling the animation for you as well. So everything's just a nicely condensed, specialized AI. So now he's doing his idle because he's got a 32% chance. Happened to do it twice by fluke. Right, now he's off. He's going somewhere else now. Right, so there we have this wandering AI. Now, the site. Let's look at the site. So, if we think a site, now I have some crazy stuff for this site, right? Like you look at. Now let's turn the debug off on the wander and look at the site debug. So it's got a nice cone, and it's got 3 rays, and there's reasons for all of that. So when you think a site, now this is one of those things, like if you're trying to build logic for a site, like how the hell do you even do that? Like where do you even start, right? And ideally, and there are numerous ways to do this. So let's open this up a bit. So we need to actually scan and kind of filter our results. So what we want to do is we actually scan all around the AI, right? We're going to scan everything there, and we're going to collect all the data. Now, our first filter, which will actually be on the scan itself, is going to be based on the layer. We're going to say, you know what, we don't need to scan and find the terrain, because we're not going to attack the terrain. We just want to find the player or other enemies, or maybe items, doors maybe, I don't know. But we actually want to scan and find everything. We're going to find everything behind the walls. We're going to find everything that's behind us, right? We don't have to react to those, but we're going to find them all. So the first step we actually do is an overlap sphere, and we go pa-doo, and we collect everything into this array. Now once we have this array, we turn around and say, okay, we need an angle, right? So we build an angle of a cone, and we say this is like 60 degrees in here. So we turn around and say, okay, we need to get the angle to every object in that array. So the first object, we say, okay, what is our angle to this object? So we take its position and our position, we subtract them in a vector operator. And I know it's already starting to sound confusing and crazy. Now we can take our forward direction, so whichever way our guy is facing, right? That direction. So say if the guy's over here, we take his position to our position, we subtract them, which actually gives us a direction. Now we can take our direction forward to this direction, and we can calculate the angle. The vector 3 operator also has an angle operator, and that's how that's actually done. But then we turn around and say, okay, we've got this angle, we've done all this frickin' math to do this angle, and we want to know if we're in this cone. So are we less than 60 degrees for this number? If yes, let's move him to this new temp array saying that he is available. If no, let's just throw him out and disregard this guy because we can't see him. He's not in our angle. All right, so that's where we look at we have our site range, the site angle. So right now that's a 94 degree angle. right? So we actually scan everything around us, but then we're going to say, you know what? It's got to be in that 94 degrees. Now, the other thing is, what if we are behind this wall, right? If we're here, let's get rid of some of that. Right. I'll even use a different color. So okay, so we're here, right? But there's a freaking wall right here. So yeah, in this circle, we're in the circle, and we are in this angle. So we should be in this list. So this list, we are in it. Everything that's out of the list, because it wasn't in the angle, so forth, but we are in this list, but we don't want to be in this list anymore. So we actually run this another step, and that's where you see these 3 rays. So I fire a ray cast, actually I fire 3 of them, and we fire it from a sight object. I use a sight object because if we use the AI object, it comes down from here at the feet, and if you have uneven terrain or a rock in the way, it'll block the ray and you're screwed. So I put it on a sight object, raise a sight object up roughly to their head, right? Like, it doesn't got to be perfect, just somewhere in there. And we fire a ray at our target. So we have to, again, get our target. If we're over here and we're here, position to position, subtract, get that angle, fire a ray from this spot to this thing, like using this angle. And then if we hit this object, right, so that's the object that's in the list, and we're going to test this object. So we fire a ray, and if this object is equal to the thing we hit, we can see it. If it can't, because we fired a ray and we hit this thing, this object is not equal to this object, therefore off the list you go, right? So if we can hit it, then it would go down to the short list, right? Now the reason why there's 3 rays is for accuracy. If your character is ducking, or your player is ducking, and you want to have that bit of accuracy, or there's maybe like a half wall or something there, and your character's walking behind it. I mean, if that ray happens to be at their hips, you know, all of a sudden you can't see them yet. You can see the top half of the character. So that's what it does. And I made a offset for that. As you see, you can build this little offset. So if you're running bigger models, you can actually increase that offset or decrease this offset, right? So but it fires 3 rays. But now with the debug, it just fires it forward just to give you an idea of the distance. In reality, these rays fire at your targets, though. They don't just fire straight. Right, so we have our sight object, our angle, the range to which how far we're going to go, the layer mask that we want to hit, the things that we're looking for. And the layer mask is for this overlap sphere. The obstacle mask, because there's 2 masks here, right? You see the ignore layer mask? That's for more for the rays. So perhaps you have a big trigger box sitting here, and your raycast can possibly hit this trigger box, but you don't want this. It's not part of the thing that AI should see, right? So we need to control these layers, right? You put the trigger box on a different layer, create a new layer, whatever the case is. So when we do our raycast and we're checking our sight, we're checking this one list here, that we just skip right through that. The ray fires right through it and says, no, screw it, we're not doing anything on that ray. So then in the end, you have this short list of objects. Then we randomly choose an object, if there's more than one. If there's only one, we choose the only object that's there. And we you know, we fire off an event saying we've seen. Actually, I just store the whole array. Actually, I don't do the random, I don't think. And if we've seen something, I do an array get, or you can do a array get random if you want it random. I'm just going to get index 0, because if you only got one thing, it's always going to be index 0. If you got two things, it'll be index 0, index 1. You got three things, index 0, 1, 2, and 3, or 1, 2. All right. So now we got a target, and then we can go into our chase. But that's how this site works. But you got to keep in mind that if we're in our idle state, site isn't working. So when we go to our idle state, if you still want your zombie to be able to see and react, it also needs that site action, right? So we put it in two states. Now, because of the fact that it fires 3 rays to test for obstacles, if it has things, right? You remember, like, it fires this ray, this overlap sphere first, which is actually really light on performance. If it doesn't see anything, that's the end of it. That's all it does. It's only when it catches possible targets that it says, okay, we need to do angle checks, right? So the performance cost is slightly higher, which is still really, really small. But when it's like, okay, it's past the angle check, now we're doing the ray cast, and we're going to do 3 ray casts. Now it is a little more costly on the performance. Still, like, don't worry too much about that. It's still pretty good. But to help ease that, is there a reason why we need to do that every single frame, like every point freaking 1, 0, 1, whatever seconds it is? You can check it out in your settings, actually. No, that's freaking insane. Like, how fast a reaction does a zombie need? Or most things. I mean, that's freaking fast, right? So you also have an option for this update time, right? So we can turn around and say, you know what, update time, we only want to check this every half a second, or I've got set for 0.1. If you want to go every 0.05 seconds, you know, fly at it. You want to go shoot every 2 seconds, you know, it'll help performance the bigger you make that number, right? So the other thing now, let me come out of play mode here for a minute, go back in, wipes out my coloring, is the chasing. So the chasing, again, is something that we could do quite easily, just making states, because all we're doing is we have a target, and there is an action called set agent. Oh God, if I could spell right. Set agent destination as game object, and it kind of more or less does the same thing, right, to a point. Now I added just a couple things. I have it so we have a speed control, right? Now again, if you wanted to adjust speed, you could do agent speed, set maximum speed, right? So that's kind of the same thing. But then I've also got it so that if this target turns null, we don't have it anymore, we've lost it. So we're going to fire off an event and go backwards. So it's kind of a bonus. To do that, I mean, you would have to add a game object is null, right? Every frame, you know, is our target null? If it's null, you know, go back. The other thing is I've also added that we've arrived. So now you'll typically stop, and there's some magic to this one. Is probably one of the easier ways to do it is actually getting distance. Is getting a distance to the target and then float compare. Right, so we turn around and we add those together. So we do our distance. I'll store that as an X maybe for now. We'll store that as an X. And if distance is, you know, less than 0.1, you know, we've arrived and we've attacked. So we have, you know, several actions. So I said, screw that, let's build it, let's make it easy. Let's just do a chase. We can control the speed. Again, we also get the animator, or that component, so we can get the speed to stick it into our animator. and we have an event for if we've arrived, an event for if we've lost the target. Now, one of the tricky things, and I've resolved it inside internally, is if you look at the NavMesh component, you can control speed here. Right now I'm controlling speed here, so this stuff actually doesn't matter. Normally I think this is like 120. So with most of my AI, I like a sharper turn. So like I crank it up to 2000, and acceleration I got to 12. But more importantly is the stopping distance. So the stopping distance, if you set it to 0, your AI wants to walk right on top, like right on top, right? And that looks stupid, it causes issues. So you got to put a stopping distance. Now the issue with stopping distances when you're doing chases and stuff is because of the braking and the bit of movements, nothing's perfect. So when you say, okay, well, when we've reached the end of our chasing, that we've got to the end of our path from the NavMesh part, we should arrive and we should fire that event. Because of the stopping distance, it'll cause issues with that, and then it just will never fire. It's got these dumb issues. I don't know. So internally, I do some math in there, and I add it in there all sneakily and hidden. So I make it so it's much more dependable. And again, we have the set the animator float, just the same. And then the attacking is a little different. Again, we set the animator float. I just do 0 this time. I don't actually give it a value because I figure we're attacking. We shouldn't be moving. And we have our model. We have our target. We have turn speed, because one of the issues with typically when you tell an agent to run to something, it'll typically always face whatever it's running to, but once it hits that point and we've reached our destination, it doesn't keep turning. It just stops until it's out of range, and then it chases it and faces it. But when it's in range, it doesn't look at our target. So I added that to the attack, so the AI will look. And then we have this attack angle. So what I say is, okay, well, we're going to control the attacking animation, but we don't want to do an attacking animation. Again, if we have a circle and I say we can only attack in this range, if my target's over here, don't play your stupid attack animation. We're not even facing the target. Spin and turn. When we're facing the target, then do your attack animation. So that's kind of what that is. Attack frequency, because like I'm keeping this attack into one action. It's just a how fast can we attack, right? So every 3 seconds we'll run our logic on this. Attack on arrival is just if the AI, like if you're over here, my AI is over here, and it's coming over, if the minute we arrive, he'll attack. If that's ticked off, the minute he arrives, he has to wait this 3 seconds or whatever you put it at, and then he'll attack. So I also do the attacks by triggers on my AI. So here I literally just have like an array, so you can literally make 50 different triggers if you wanted to, right? And we have a weighted value. So trigger, we'll say attack and attack 1. And if I look in my animator, I made 2 parameters, attack 1, right? So if I get this guy, attack 1, we do this one. If I get the trigger attack, we do this one. So there, now we have, it'll randomly choose those, and it's chosen on weight, right? And if you haven't seen weight before, so if I go, and set this like, like this, it'll almost always choose this one, but once in a while it'll choose this attack 1. You put them kind of closer together, or you put them both maxed, they'll be 50-50. The other thing is if the attack also watches distances. So if we are out of range, I just use the event scene. I don't know why I use scene. it just kicks it back into the chase state, saying, hey, we're out of range. Like, chase this frickin' target down. Like, we need to be attacking them. So we chase it, get close, go back to the attack state. And if we have no target, we're just going to go back, and we're going to go back into our wandering state. So there's our 3 states. Right? So if I come along, enable his logic, we can see he is doing his little wander, and if I grab our box, which has got the right layer, and I slide him over, I can see it now, and now he's doing a run. Right? And when he gets to us, you see how he stops at that distance, 1.75, and every 3 seconds, which includes the time of the animation. Like if the animation's a 1.8 second animation, that's all included. So it's only technically a 1.2 second delay in between. Now he's doing his attacks. Right, pretty cool. So let's just quickly look at this again, because it almost looked like his angle was really, really wide there. Maybe I just came in at a funky angle. So let's check that again. So let's take our guy. So we're behind him. Oh, I do have an issue with the angle. All right, so I'll have to fix that up. I did have it working earlier, so I must have did something. I'll fix that before I upload the actions. But yeah, so anyways, the model technically doesn't matter, right? Like if I take this guy, let's pull him out for a minute. Let's put him into my XCOM so I know where he is. And if I take the model and delete the model, grab a different model, any model. I'll go back in here. Let's go with this model, stick it in there, and where's my XCOM? There's our animator. Let's make sure we put the same animator. Turn off root motion. Now you could obviously build on this animation and build more attacks and all sorts of stuff, but now technically, because all my logic isn't on the model, it's on an empty, and let's turn him on. I have my model as a variable. I just drag my model in and hit play, and that's literally all I have to do. And my model, well, it'll act like a zombie because that's the animator, but it works just fine. Right? There he is attacking. Blah, blah, attack, kill, blood, die. Right, so that's pretty cool. Like I said, now I gotta fix the angle. There's something more weird with that angle, but I'll fix that. That's minor. So one of the other things, and I'll get this before I call this quits on the video, is because this seems to be a common thing. Let's say I have an FSM, and it's called health. So a health FSM, keep that in mind. And we add a state, and we make a state or a global event, custom event. I've already got a whole bunch of these, so I'll just reuse one of these, I suppose, called damage, right? And damage is a global event. And I'll do get event properties. So let's do a properties. Let's do a key. What are keys? Keys are literally just a name for something that's being loaded. So let's call it, you know, zombie damage. You can literally call it anything you want. We'll use an integer, and we'll make a variable now, and we'll set it in the damage. Right? So that could be the starting of a health system. So zombie-wise, now this has to actually go on the model. because we're going to feed off of the animator for this. You don't necessarily have to. There's numerous ways to do this. But let's say we make an event called, I don't know, attack, action. I can use action. Oh, there's attack. All right, which is just another global event, nothing special. And if we get that, so let's say get parent. I like to do things by variables instead of dragging things in. It's kind of the better way to do things. So there's parent. So that means if this guy, he's saying in the start, we're going to get our parent. Our parent is this guy. So we need to get FSM game object from our parent. And the way I like to, oh, sorry, not there, over here. So getting parents, all we need there. In the attack, when we attack, I'm just going to drag him in for a minute and say, okay, our FSM has a target. We want the target because that's the target our AI is chasing. That's the target our AI is doing everything to, right? So I'm going to use the parent here, right? So that's this FSM. So I'm going into this FSM to grab its target when the attack is called. I can now do, say, a random int, right? Maybe, 10 to 50. We'll call this our damage, and let's set event properties, and that is bloop, bloop. Oh yeah. And I've already forgot what the hell I freaking called that stupid thing. So now I gotta go into the cube. What did we call it? Zombie damage, right? Because the names have to match. That's the key. Hence, they're also called key. But okay, so zombie damage. So that's the key of this property that we're making. It is a type integer, and we're going to fill it with this random damage. Now, let's send event. All right. So we're going to send an event to our target. So we don't want to use the owner. We want to use a variable of our target. We know our target's going to have an FSM called health, and we know it's going to have the health FSM has damage. So we load in this variable into this event, and we fire the event off. It's kind of like putting a little rock in a snowball, throwing the snowball at someone. It's like, here, catch a rock, a-hole, right? So how do we trigger this attack? Well, there's numerous ways to do that. I find the best one is, say we go to this attack animation. Go right to the animation and go into here. If you don't have the FBX, you can go in the animation here and do it through this. Oh, they're not. Oh yeah, the attack is a read only, right? But normally, yeah, like they're read onlys. But if you go into the FBX and I go to the animation, I say events. Let's open that up, and we can turn around and say, all right, so this is our little zombie guy here. We'll pretend, and we attack. So right at a certain point, so he's kind of doing a double attack, and that's fine. We can go right there and say, let's send an event. So the event we actually want to call is a function, and that function is through Playmaker, and it's called send event, because that's what we want to do. We want to send an event, right? The string, which is the actual event name we want, is attack, right? Now I can come along over here and say, all right, we're doing it again. Say right there. So let's send event attack, and then whatever the hell this one is, 2 damage, must have been from another tutorial. Let's apply that, right? So we have send event. Now if I go into the other attack, see how this one isn't in an FBX, right? So this one here, a very weird one. Alright, where is it? The attack. Right, so I can see it now. I can scroll through here. But it's the same thing, right? So I say, alright, so it's just a weird attack. I don't know why it's original. It's 90. It's all baked in the pose. Alright, whatever. So anyways, oh, not to walk the attack. So we say, alright, so say right out maybe there we want the damage. We can hit this little guy. It's the same thing. We add an event. We can click on it. Over in the inspector now we can see no function selected, so we can say, alright, so we can call any kind of functions. Now the one we want is send event, right? So FSM, which is send event, which is a string, and we can say attack. We'll use that same string, right? So it's exactly the same thing. It's just kind of once through the animation, once through the FBX. And that's literally it. So now, if I hit play, and we see our little cube, and if I actually open this up, and we take our little cube here, we can see that damage, the double swing. See that? Oh, let's bring over the numbers. Right, 13, 14, or 34, 13, 18, 15, right? And that's because over here, when that animation plays in the animator, that send event is getting fed to this object though, which is why this has to be on the animator. To this object, it's sending our attack event. Through our attack event, we say, okay, well, we know our parent is the AI because we got that in the start, and we have we're going to go into our FSM here, right? And you can change the name of this and just change the name of that. We select all our random stuff. We set that rock into the snowball right here, and then we're going to throw that snowball at our target. Right now with AI, you'll notice that for me, I don't like using like the hitboxes and stuff and things like that for the AI. I use those for the player for sure, no problem. For AI, I found it's nothing but issues, right? Like you put a sword in the AI's hand, they go to do a swing, depending on how they're lined up and stuff, they might be missing the character by just a tiny bit. AI doesn't know that because they haven't been told to watch for that. So your player just stands there and the AI is swinging and the sword's just going off to the side. It's all crazy and it's stupid. It doesn't work, right? It's nothing but issues. So what I find is if the AI is to the point that they're doing the attack, the logic's already here. We do the attack when we're facing and within range, right? We have everything there. If we're not facing, we don't do the attack, right? If we're not in range, we don't do the attack. A lot different than a player, because a player can just hit a button and do the attack. He doesn't need anyone in front of him, right? So there needs to be hitboxes there. For AI, it's controlled by the logic that's even doing the whole attack state to begin with, right? So if I move, he stops attacking, plain and simple, right? So I technically don't need any checks in here at all. I don't need hitboxes on my AI to attack my player. I need them to attack my AI, sure. I don't need my AI to do raycast and all sorts of stuff in this situation. Now, if it was guns and projectiles, kind of a different story, right? Now, if I really wanted to, I could add some stuff here, more angle checks and distance checks, right? Because maybe your player can dodge. and stuff. So in those cases, I'd probably just add an angle check, right? Like if my character dodged during the attack, you could say, oh, well, I dodged. The other thing you could do is that if you dodge, this person, you know, maybe he runs a bool saying is dodging, and it lasts for 0.5 seconds. And then not doing anything with the AI at that point in time, but over on the health, we check is dodging. If dodging is true, as we're moving this, ignore this damage. Just don't add it. Don't do the blood. Don't reduce the health. Just ignore it. You know, play your dodge effects. If we're not dodging, do the damage. Right? Pretty simple. But anyway, so there is my zombie AI simplified. Right, so we have this nice little zombie AI with sight. So there's something wrong with my angle checking on it, but that was probably because I was playing around with the debug portion of it. Probably, you know, put a bracket in the wrong frickin' spot. So I'll fix that up real quick, and then I'll probably, while this video is more or less being edited, and then I'll put that all up on my Patreon. Well, actually, I'll put the video on YouTube as unlisted again. That's not a big deal. But I'll put the actions on the Patreon part. So the only other thing I could possibly think of to even add in here is to raycast to the player once in a while, and if the player gets behind an object, to do some more logic, another state, a hunting state or something, where you lost memory state. But beyond that, it is very, very simplistic. Look at that, 4 states, and that one's okay, 5 states. 5 states, and there's an entire zombie AI with cone and obstacle sight, with a wandering system and an attacking system, all kind of built in. So hopefully you learned a lot. I know I did. Talk to you later.